We're gonna write a program to find the statistic feature of a list. So for example, we're gonna write a Python program to find the max, the mean. Okay, I have to a little bit adjustment there. I have to turn this down. We're gonna do the code. Okay, and the average of the average of a list. So and for if possible, we're gonna say also write a program to find the second biggest number of the list as well. So to find the second biggest number, second uh, biggest number of the list. Okay, so for example, we have a list here, a Python list. So we're gonna let list name list1, and it's gonna be equal to a list of number. Let's put in number, for example 3, 4. We couldn't put in negative number as well. We can also put in decimal. Could put in negative decimal, some more number, 9. So 0 minus 1, 3.5, and this point. And let's have a couple more. For example, 10 and for example 3.4514. Okay, so that's our list. So now I want to find the max of the number. So I can call the function def find max of a list of a list x. Okay, so for I element in list x. Okay, so now to find the max of the list, we're gonna now firstly assume that the first element, the first number of list x is actually the max. So because Python index starting from 0, so the syntax gonna be, we're gonna let list x index number 0 gonna be the max. So max equal to list x number 0. Okay, so we're gonna announce, we're gonna set the first element of the list to be the max, and now we're gonna look through the list, to find the actual max. So let's think about this. When we set the first number of the list to be the max, and we're gonna look through the list, we're gonna compare each following elements with the max that we set out, which is the first element. Now if the comparison result in the smaller result, which means the following element is less than list x number 0, the first element, then the max not gonna change. The max gonna still say as list 1 number 0, right? Because like for example if the list was like 5, 4, 3, 2, 2, then each of these elements is actually less than list number 0, right? The first element. So the max is going to be say the same. However, if in the process of looping we find another number that is actually bigger than the list number 0, so then that new element is actually the new max, right? So with that logic in mind, with that idea in mind, we're gonna implement this algorithm by Python code. So for element in list x, okay, so if element okay bigger than max, Then we're gonna set the max to be the new element, right? Okay. So for example here in this list, uh, for example here in this list, now we're gonna set the max to be 5, and now we compare, we want to look for number 4. So because 4 is less than 5, so the max now is still be equal to 5. Okay, so let's put a couple more here to make sure you understand the algorithms. So because 4 is less than 5, so the max is 5. Now which is, here is list number 0, right? List index of 0. Now is list 1. Okay, so we have an array of number here, 4, 3, 2, 1, 6, and 0. So alright. So now max is 5 because 4 is less than 5, then the max is still 5. Okay, so we're gonna come to the next iteration. So this one. So now because 3 now is less than 5, so we're gonna come through the each element, we're gonna compare it with the max. So smaller than max. Okay, so because max is equal to 5, so now max is equal to still 5, right? So same thing with 2. Same thing with 2. So because 2 is smaller than max, so now max is still equal to 5, right? However, on the next comparison, okay, so now 6 now is actually bigger than max. Then you have to set max to a new value. So max now is equal to 6, okay? And we have to take note of that. Max now is equal to 6, so we have to update the max, okay? Okay, so now we're gonna keep comparing. So because 1 is less than max equal to 6, max, we have to compare 1, next element, with the new max. So max now is equal to 6. So because the next element is, you know, like less than the max, so the max gonna stay the same. Okay, so anyway, in here we're gonna return max, and we're gonna have a prom as well. So the biggest, the max of the list is the maximum of the list is, okay, and max, okay. Alright, so now we're gonna have to keep looping, right? So we're gonna loop through 2, the next element is 2, so is the max now gonna be still equal to 6 because it's less than the max. So and the last element is 0, so now it is so anyway, after this process the max going to stay at 6 because, you know, every element is less than the max. So now we can return, alright, max equal to 6, right? So that's the algorithms. So let's check it out. So print find max of list 1. Okay, let's run. Okay, so I'm gonna save it as desktop, and I got this test. Okay. Okay, the max of this one is 10. So okay, so that's correct. So we're going to find the algorithm for the minimum of the list, which is very similar. So it's just the reverse of this 5-mark algorithm with the exact same implementations. So it's going to be very similar to the 5-mark functions. So it should be like this. Okay, so let's analyze this list again. So let's find mean. Alright, now we find mean. So this is 5 marks, and this is 5 mean. So still with the list, and now we're gonna also set the first element to be the mean, right? So all of this getting a little bit delayed. So now we're gonna set the mean to be the first element, same as the algorithm before, and we're gonna look through the list. We're gonna compare each element in the list with the mean that we have set out. So we're gonna compare each element of the list with the mean that we have set out. So now, because 4 is less than mean, so now mean gonna be changed to 4 because you know the mean is changing, right? Mean is equal to 4. Now 3 is less than mean, which is mean is equal to 4, right? Equal to 4, right? So mean is now equal to 3, right? Right. So now next 2 is now okay, still less than the mean equal to 3 as mean, right? So now the mean is updated to 2, right? Mean is updated to 2, right? Okay, mean is updated to 2. Okay, so now 6 is actually bigger than mean, so the mean gonna stay the same, right? So mean is stay the same as 2 because 6 is actually bigger than mean. It's equal to 2. It stays the same, right? Now 1 is actually now less than mean, so mean has to be updated again. So now mean has to be updated again, so mean will now be gonna be 1. And now 2 is now actually bigger than mean, so mean gonna stay the same, right? So mean now, because mean previously is 1, so here mean has to be also be 1. Okay, and lastly, because 0 is actually less than mean, so right, because mean now equal to 1 and 0 is less to mean, so now mean now has to be updated to be 0. Alright, so did we put a negative number in? No. So this is the hypothesis, so this algorithm explanation, but when it return, it's gonna be here, it's gonna return for us the negative number in our real exercises. This is just a algorithm explanations. So return mean equal to 0. Okay, so that's the algorithms equal to 0. So in this case, we're gonna have similar function here. So we're gonna def find mean. And also our input gonna be a random list for list x for consistency with the def mark functions. Okay. Okay. So now we're gonna set mean to be the first element of the list, number 0, and also we copy the algorithm with the change of the sign. So if element is smaller than the mean, then the mean is going to be updated to be the new element, right? Okay, so the minimum, and we're gonna return the minimum of the list is, and we're gonna return the minimum. Okay, so now let's print min, find min of list 1. So the algorithm is exactly the same, it's just the opposite side, because for the max we're gonna find out what is bigger than the initial point, and for the mean we're gonna find out what is the bigger that are gonna be smaller than the initial point. So with this we are expected it the function to generate 10, and with this we're gonna expect the function to generate -5, right? -5. Okay, this is just a mock algorithm down here. Okay, so let's save and run. Here it's -5, that is correct. Okay, now okay, so that's very good. It has returned the correct result. Okay, so we're gonna call this mock algorithm. So testing out the logics, right? Okay, so now we want to do the second part of the algorithm. We're gonna find the second biggest number of the list. Okay, so we have find the max of the list, which is 10. So now as you can observe here from the list, we know that if you want to return the second biggest number, should be 9, right? Should return 9. So we have to find a function that somehow it return 9. Okay, so let's think about that. If now we know the max of the list is 10, so now if we remove 10 from the list, then the second number gonna be the second number, which is 9, the second biggest number now is actually 9, gonna be actually the max. And if we return that number after removal of 10, we actually return the second biggest number in the original list, right? Okay, so let's demonstrate it down here. So we're gonna use our actual list now. So no more no more mock. Yeah, I'm gonna use this one. So no more mock list. So 5 second biggest, second biggest. So this is our list here. So now our first step is remove max equal to 10. So our list gonna be now, so list 1 now gonna be like this. So we remove 10, right? So remove 10, so delete 10 away, right? So here is list 1 now, right? So as you can see now, the second biggest is now actually the max of the new list 1, right? So now what we in order to find the second biggest, we has to be return now the max of list 1. Okay, so actually to denote it carefully, so I'm gonna say this is list 1 update. So list 1 update is equal to this one dot remove max of this one, right? So return the max of list 1 update. Okay, so that's gonna be the algorithm that I'm gonna implement to find the second biggest number inside the list. Okay, so let's implement that. So def find the second biggest number, second biggest number. Okay, so Wanna enter a list one. List X, right? List X. So now, now, what you gonna do? We're gonna set the removal variable, removal equal to list X dot max of the max of list X. You can use this function, right? So removal of max of list X. So list X now going to be updated to be list X dot remove removal. So we have to think a little bit. So how we remove a number. So this. Okay, so let's test some method in the list. So this one dot, what's the method here? Remove. We have the method of remove here. So list X dot remove removal. Okay, and now we can return the max of list X, the new max of list X. Okay, so now we call it the second biggest number in the list is, and we'll return the max of list X after the removal. Okay, so let's try to run it, and in this case we want it to return 9. Okay, so print, let's test it out. So print second 5 biggest of this one. So I want it to return 9. Okay, so let's see. 5 save run. It's 9, which is correct. Okay, so okay, so that was actually a good algorithms. That's actually a good algorithms, and you can test it out with a hypothesis list there. So this list one. So you can test it out with a test list that we are using down there. So that was good. It actually returned 9. Yeah, 9 is actually the second biggest. So I think that's the end of the lesson. So thank you very much for listening. So if you have any comments, if you want me to do anything, please comment down section down below, and I'm gonna prepare it. I'm gonna try to teach it for you. Okay. So thank you very much. Have a good day. Have a good day. Goodbye.